The following is a quick video about distributed database management systems. Distributed database management systems consist of both homogeneous and heterogeneous systems. Homogeneous systems use the same DBMS at all locations. They can be easier to implement and maintain because they use the same components across all sites. Heterogeneous systems use at least one different DBMS throughout the various locations. They can be more difficult to implement and maintain because they can use different data types, run on different platforms, and can require translation for the different systems to communicate. There are many similarities between homogeneous and heterogeneous systems. Both handle collections of logically related shared data. Data is normally split into fragments, which can also be replicated. The systems are connected to a network. Every site has its own DBMS. Local requests must be handled autonomously, and each site must participate in at least one global application. Many different companies use distributed database management systems. Basically, any large company with multiple locations who has a need to store data is a good candidate. Amazon, Google, Yahoo, they all use distributed database management systems. Financial institutions also use distributed database management systems. They're fast, secure, redundant, fault-tolerant, and easily scalable. There are several reasons why you'd use a distributed database management system versus a centralized database management system. A centralized system can be cheaper in the short term. They're simple, there's not any redundancy, and there's easy access because it's housed in one location. A distributed database management system can be cheaper in the long term. They're highly scalable, they have good availability because they can use redundant hardware and software across multiple sites, along with redundant communication and networking paths. They are very high performance systems because the network traffic can be divided between multiple locations along with the processing capabilities. A homogeneous distributed database management system seems to have many benefits over a heterogeneous system. However, there are a few reasons why you would want to use a heterogeneous system. One could be the expansion of an obsolete system. You may not be able to get new hardware and software that is compatible with the old system, and you may not want to merge it all into a new system. In this case, you'd have two dissimilar systems equaling a heterogeneous system. This could also happen with a merger and an acquisition. You can have two systems working perfectly fine and have no need to actually convert them into one similar system. The last reason could be because you want to use different database models. You may want to use a relational database in one place, and you may want to use a graphical database in another. Not all database management systems are capable of storing data in different database models or formats. Therefore, you would have to use two different database softwares, which would also end up in a heterogeneous system. Date came up with 12 rules that a distributed database management system should follow. In this slide, we're going to focus on 9 through 12. Number 9 is hardware independence. Hardware independence means the database should be capable of running on multiple different hardware systems. There are a lot of hardware systems out there, including NVIDIA, AMD, Intel, Apple, Microsoft, EVGA, Qualcomm. Very difficult to design something to run on all of this hardware. Number 10 is operating system independence. Again, this is a difficult task. There's a lot of different operating systems out there: iOS, Android, Mac OS, Windows. It's difficult to make this software run on all different operating systems. Number 11 is network independence. This one seems to be a little bit easier. There are good standards for network compliance, and it seems most stuff seems to be capable of communicating on different network types. Rule 12 is database management system independence, and this may be the most difficult. There's all different kinds of databases out there running different types of languages, and there doesn't really seem to be any type of standard between them. There is no translation program that translates between all of the different databases, and it can be very difficult for them all to communicate well with one another. Are there any distributed database management systems that follow all of DATE's 12 rules? The short answer is no. It's very difficult to follow all of these rules. Now, I think the first 8 rules are probably able to be complied with. They seem reasonable. 9 through 12, which we talked about in the previous slide, are very difficult, and it would be a tall task to comply with all of those. There are many open source distributed database management systems available. A few of them are highlighted on this slide. Apache Ignite, for example, is very good at data caching. It's durable, highly available, and has consistent data persistence. It's also easily scalable. Foundation DP includes support for multiple data models. It is high performance, fault tolerant, and also highly scalable. Yugabyte DB is a relational database model. It has global storage capabilities with data served locally for low latency support. There are many more open source database management systems. Some of them are good at one thing, some of them are good at a lot of things, some of them aren't very good at all. You should be able to find something to suit your needs. Thank you for viewing my video on distributed database management systems. I hope you learned something and are able to put it to good use.